Part D of Module 4. The topic, selection problem and a recursion tree. But before I talk about these two topics, I want to explain a few more questions in your homework assignment number 1. I already explained 8 questions in Part C, the last 2 videos of Part C. But I feel it may not be enough because we have total 25 questions. I just covered 8 questions. Still, there are 17 questions. Still, you may have many of them. You may have a lot of questions. So I will use another 2 videos to explain a few more questions. So 6 more. So this video, D.1, I cover 3 questions. The next one, D.2, I cover another 3 questions. So total 6 questions. 6 plus that 8, 14. 14 out of 25 explain. Hope it helps you solve the whole assignment, HW1. All right, so let's start. The first one, question number 6. It is pretty easy. If you have questions, so here I explain the way I feel, the good way to solve. So first, this is a large number, so I do not, you may try to calculate it. So it's okay if you want to really calculate what is this number, that's fine. Okay? But here I recommend using a simple way, a smart way to do it, not a tedious way to do it. All right? Yeah. We want to estimate this number because that -1 is not important. Right? Not important. We estimate. So +1, even +100, it's not important. Right? Yeah. All right. So then we use I like you to use one special estimate. We use it a lot. In computer science, we use a lot. Okay. So that is 2 to the 10, approximately equal to 10 cubed. 10 cubed. 2 to the 10th, that's 1024, right? Exact number. Is it pretty close to 1000? Yeah. This one, 1 kilo, right? 1K. Yeah. This byte, when we have 2 to the 10th bytes, that's 1 KB, right? 1 kilobytes. We use that. So when we start, we use that approximately. All right. So now, 2 to the 64th. So let's write 2 to the 4th times 2 to the 60th. How about that? Okay. 2 to the 4th, that's 16 times 2 to the 10th to the 6th. How about that? 6 times 10 is split. Okay. 2 levels. Can we replace it by 10 cubed? Or this time approximately times 10 cubed 6. How about that? Yeah, right? Yeah. So from there, so you try to figure out. So You try to figure out. So that's pretty close. You're trying to figure out which one is the closest. Right? Yeah. Closest. Which expression closest to this one? Okay. Yeah. That's this question. This one. Growth function. This one, based on my experience, many of you could miss it. Many of you could miss it. Because when people solve it, they make their decisions by their intuition. Sometimes your intuition may not be very reliable. Okay? So that's why you get a wrong impression. So you make a wrong decision. Here. So let me point important things out. So you need to really think about it before you make your decision. First, so this one, when we talk about growth functions, we can ignore minor terms, right? So this is approximately n. Okay? Yeah. So this one we just consider n. So this one, n to the square root, 1/2, right? Yeah, but log n, so log n. So here we need to know that log n. Log n, we use it frequently. Yeah. Here I like to give you the reference we used the last time. Yeah. Module 2. Part D.3, okay, page 4, okay, yeah. So example 2.B3.7. In that one, we prove with this result. Log of n belongs to little o of n to the d for any d greater than 0. D, just a positive constant number, no matter what. It is positive. It is positive. Okay? All right. Now, the critical point, you need to really pay attention. Is this number positive? This is our d. Although it is very small, but it is d, it is positive. Okay? Can we treat this expression as n to the d? Right? So when we treat it as n to the d, now you compare log n with this one. Can you use this? This, we prove it. We use L'Hopital's rule. We prove it. Yeah. So if you still, if you are not convinced, you can study our proof. We give a very rigorous proof. Try to understand. Then, because this result may be against your intuition. Your intuition will tell you a different way. So it is against your intuition. Yeah. So that decision is hard to make. Okay? Yeah. So that's why if you're not convinced, you study the proof of this example. So then, hope it helps. Yeah. All right, so that's this problem. The last one of this video. Each one I just cover 3 questions. All right. So this one, some student may be scared by this question. Yeah, because when you look at the expression, it looks so complicated. Here, we need to use pi, so we know that pi, right? 3.142, something. Yeah. 5, I cannot memorize many digits. Yeah. All right. And golden ratio, we have that expression, right? E, natural log base, yeah, so we can find it 2.71828, that one. Yeah. All right. So here, to answer this question, do not plug in those numbers and check. Do not plug in those numbers and check if they are really integers or not. Yeah. Although you can do that if you like. Yeah. If you like. Yeah. But the reason I give you this question, I want you to connect to something we have learned in our lectures, in our notes, something we learned. If you can connect to it, then you can make the correct choice, decision, easily. Yeah. All right, so let me give you the reference. Module 3, part C.2, page 1. In that page, you can find Fibonacci formula. After you find the Fibonacci formula, then you look at this question, you compare, you think about it, then your answer is there. Yeah? Otherwise, if you don't have the background, if you don't have the Fibonacci background, okay? I do not want to tell you the answer. If you do not have the Fibonacci background, for most people, they just would make the random pick. Because for those people, there is no difference. Pi, E, phi, all these three symbols, just three different symbols, they couldn't see any difference among them. So they just make the random pick. But for us, we have the Fibonacci formula. We have that background. So we should not make our random choice here. We need to make the reasonable, good choice here. All right, so that's the D.1, the first 3 questions. D.2, the last 3 questions. Then I won't talk about more questions. 14 out of 25 should be pretty enough for you. Yeah. All right, so let's stop here.